The world of generative AI has exploded with innovation. From the powerful models to the engineering tools, real-world applications, and underlying infrastructure, it's a rapidly evolving field. In this video, we'll explore the current state of this transformative technology and unveil the Gartner Hype Cycle to show the exciting possibilities on the horizon and guide you avoid the trough and embrace the future. There's debate about the true potential of generative AI. Some AI researchers are skeptical, calling large language models stochastic parrots that simply regurgitate information. Others believe generative AI is showing signs of human-like intelligence, like becoming multimodal, learning like humans, and exhibiting reasoning capabilities. The debate shouldn't distract from the progress and potential of generative AI. Generative AI has made significant progress in recent years. It has the potential to enable many useful applications within organizations. There is a significant increase in optimism among executives regarding generative AI. A poll conducted by Gartner in September 2023 showed that 78% of executives believe the benefits outweigh the risks. This is a 10% increase from April 2023. Reasons for optimism are: first, mitigation techniques. There are emerging techniques to mitigate risks associated with generative AI, such as hallucination generating unrealistic outputs and data privacy concerns. Second, general optimism for new technologies. There's a natural tendency to be optimistic about new technologies, and generative AI is no exception. This excitement might overshadow the potential risks highlighted by the research community. Overall, the sentiment from executives is highly positive regarding generative AI, with a growing belief in its potential benefits and a perception that the risks can be mitigated. There has been a substantial rise in generative AI adoption among enterprises. In April 2023, only 20% of respondents indicated running generative AI workloads in pilot or production. By September 2023, that number jumped to 55%, representing a 36 percentage point increase in just 5 months. Gen AI is being utilized across various domains within enterprises. Here are some examples. First, natural language processing. This includes applications like chatbots, question answering systems, summarization, translation, and sentiment analysis. Second, software engineering. Gen AI is used for code generation, completion, documentation, and search. Third, other IT applications. Potential future use cases include data and analytics, security engineering, DevOps, and cloud computing. Fourth, computer vision. This involves using text input to generate visual outputs like images, for example, DALL-E, Midjourney, Stable Diffusion, Firefly. Potential applications span industries like insurance, media, gaming, oil and gas, and agriculture. Gen AI will see even broader adoption in the coming years, potentially impacting fields like scientific research through drug discovery and chemical formulation. How to avoid the trough and embrace the future. First, Amara's Law. We might be overestimating Gen AI in the short term and underestimating its long-term potential, following the principle of Amara's Law. Second, risks of Gen AI. There are significant risks associated with Gen AI that need to be addressed, such as data privacy, hallucinations meaning generating unrealistic outputs, legal implications, for example, copyright, unregulated AI. Regulations are emerging, for example, EU AI Act, requiring mitigation strategies. Third, focus on internal use cases. Due to the aforementioned risks, many Gen AI use cases today are internal-facing within enterprises, limiting exposure to external customers. Overall, it's important to consider the need to address risks and challenges before fully realizing the potential of Gen AI. This image describes Gartner Hype Cycle as a visual representation of the stages a technology typically goes through over time. It's illustrated as a roller coaster with distinct phases. First, innovation trigger. A new technology is invented and sparks initial interest. Second, peak of inflated expectations. Media attention intensifies, and expectations for the technology's capabilities become unrealistic. Third, trough of disillusionment. When the technology fails to meet inflated expectations, disappointment sets in, and some abandon it. Fourth, slope of enlightenment. A more practical understanding of the technology's true potential emerges. Fifth, plateau of productivity. The technology is applied appropriately, delivering real value and becoming widely adopted. Gen AI is currently somewhere between the innovation trigger and peak of inflated expectations. There's a lot of excitement, but also a risk of overestimating its immediate capabilities. Gen AI is in the early stages of the hype cycle, between the innovation trigger and peak of inflated expectations. There's a lot of excitement about its potential, but expectations might be unrealistic. The image depicts the Gartner Hype Cycle with its well-known 5 phases. All the Gen AI technologies listed on the y-axis of the image are currently in the first 2 phases: innovation trigger or peak of inflated expectations. This reflects the relative youth of the field. Here is a 4-layer stack representing the key elements of Gen AI. Models. These are the core Gen AI models like GPT-4, Gemini, and Stable Diffusion. Engineering tools. Tools to automate, validate, and enhance the models. Applications. Practical applications built on the models, such as ChatGPT. Infrastructure. The underlying infrastructure needed to train and use the models. We will delve deeper into each of these layers in the following slides. The trends related to Gen AI models are selected in the Hype Cycle image. Foundation models. These are general-purpose models trained on large amounts of data. Examples include language models and computer vision models for tasks like image segmentation and object detection. Large language models, or LLMs, a subset of foundation models that take text as input and generate text as output. 2023 was a big year for LLMs, but there's also growing awareness of their limitations. Domain-specific models. Models trained for specific tasks or industries, such as a financial services model trained on stock market data. Open-source LLMs. An exciting trend is the emergence of open-source LLMs like Llama 2 from Meta. These models are competitive with proprietary models and can be freely used and customized for commercial applications. Open-source models are also lighter weight, making them suitable for deployment on edge devices. Edge LLMs. LLMs optimized to run on devices like smartphones. Model hubs. Platforms like Hugging Face that make it easier for developers to discover and use generative AI models. Multimodal Gen AI. The future of Gen AI lies in models that can combine different modalities like language, image, and audio. Examples include Google's Gemini and OpenAI's GPT for vision. We think that artificial general intelligence, or a GI, is still very, very far away. We believe that there are missing elements, many breakthroughs that are needed on the research side to get to something like human-level intelligence. Now, I describe the concept of engineering tools and their role to drive real value from Gen AI models. Here's a breakdown of the key points. Prompt engineering. Techniques for guiding LLMs towards desired outputs through prompts. Tools can automate prompt creation or suggest best practices. LangUps. Tools that manage the entire life cycle of large language models, or LLMs. This includes data curation and retrieval, fine-tuning, deployment, and monitoring, LangGAPS becomes increasingly important as LLM-based applications transition from pilots to production in 2024. Retrieval Augmented Generation, or RAG, a method for incorporating an organization's data into the LLM generation process. This can improve the model's performance on specific tasks. Reinforcement Learning with Human Feedback, or LHF, a technique for training LLMs based on human feedback. This is essential for shaping the model's behavior and preferences. Vector databases, databases that store information along with numerical representations or vectors of their meaning. This is useful for searching related information based on user queries. Model orchestration. Many organizations will use multiple generative AI models for different tasks. Model orchestration tools like LangChain or Llama Index help coordinate these models and their outputs. Overall, engineering tools bridge the gap between LLMs and real-world Gen AI applications by providing the necessary tools for managing the model lifecycle and interactions. The real value that comes from Gen AI is applications. Here's a breakdown of the key points of Gen AI applications. The Gen AI hype cycle is currently dominated by applications in the early stages, innovation trigger, or peak of inflated expectations. A wide range of Gen AI applications are emerging, including virtual assistants like ChatGPT, Gen AI-enabled applications, or existing applications with Gen AI features like Adobe Firefly, software engineering tools like GitHub Copilot and Replit. AI Trism stands for AI Trust, Risk, and Security Management is becoming increasingly important as organizations look to mitigate the risks associated with Gen AI models, including bias, toxicity, hallucinations, inaccuracies. Synthetic data is another area that benefits from Gen AI. As generative models improve, they can be used to create higher quality synthetic data for training other models and for privacy preservation. Autonomous agents, which can take high-level instructions from users and break them down into a series of tasks, are a long-term trend, but there are early signs of progress in this area with tools like AutoGPT. None of these applications are possible without the underlying infrastructure and enabling techniques, which will be covered in the next part of the presentation. Compute infrastructure and enablement techniques are critical elements for Gen AI. Here's a breakdown of the key points. Gen AI workload accelerators include: first, current hardware. GPUs are the dominant hardware for training large language models and foundation models due to their processing power. Second, future hardware. There is growing interest in other specialized compute platforms like ASICs or application-specific integrated circuits that could offer greater efficiency in energy and cost for training Gen AI models. Third, edge LLMs. Smaller, less powerful models are being developed to run on mobile devices with the help of neural chips. Gen AI enablement techniques include: first, self-supervised learning, a technique where models train themselves by analyzing large amounts of data from the internet. Second, AI simulation, creating simulations of the real world that models can learn from. This is especially useful for generating synthetic data. Third, transfer learning, a technique where a model trained for one task is adapted to perform a different but related task. This is useful for fine-tuning Gen AI models for specific applications. Gen AI builds on previous AI research and techniques. Self-supervised learning, AI simulation, and transfer learning are all important contributors to the development of Gen AI models. This is a prioritization framework that considers both the potential benefit of a technology and the time it will take to reach mainstream adoption. According to the graphic, Gen AI-enabled applications and virtual assistants with RAG are some of the technologies expected to be mainstream in the next 2 years. Here are some suggestions for organizations based on this framework in 3 future time duration. First, in near-term adoption, within 2 years. Identify existing applications. Explore solutions like Gen AI-powered code completion tools or AI-powered chatbots to automate repetitive tasks and improve efficiency. Second, in mid-term adoption, between 2 to 5 years, experiment with open source options. Test open source LLMs and prompt engineering tools to understand their capabilities and identify potential use cases within your organization. Invest in developer training. Equip your software development teams with the skills to leverage Gen AI tools for code generation, search, and documentation. Explore data integration. Investigate how Gen AI can improve data management and analytics by transforming unstructured data into insights. Third, in long-term adoption, more than 5 years, stay informed. Follow advancements in autonomous agents and synthetic data generation. These fields hold significant potential for future automation and data-driven decision-making. Develop a long-term strategy. Start brainstorming how these long-term applications might impact your industry and explore potential pilot projects to test their feasibility. It's important to remember that AGI is still a theoretical concept, but the continuous development in these long-term Gen AI applications is a significant step towards that future. By following these suggestions and leveraging the Gartner framework, organizations can take a strategic approach to Gen AI adoption and unlock its potential for increased efficiency, innovation, and future growth. Are you wondering how to leverage Gen AI in your job? At AI4Job, we're all about helping you navigate the future of job. So, what can you do next? Contact us by email to discuss custom AI solutions for your job. Leave a comment below and tell us, what Gen AI applications are you most interested in for your job? Hit the subscribe button. We'll be covering more emerging AI trends and how they affect your job prospects. And check out the link in the description for the full Gartner webinar on Generative AI Hype Cycle.